Hello, everybody. Welcome to the day. We are on our fourth day of SSAA FacTOR. To be is to build, and today is a very exciting day. We are going to have our. We are going to look at the different journeys of alumni practices and how they have dealt with the construction technologies in the practice of architecture. So, without much ado, I would like to introduce our Purva Chawla, founder of Material Driven, Dallas, London. She's an alumni of SSA 2007 to 2011. Purva Chawla, she is, of course, an architect and a material expert, and she's the founder and partner at Material Driven, a design agency and materials library operating across continents in the UK, US, and Spain. She has worked at several architectural firms in the US and India. She launched Material Driven in 2016, intending to broadcast advanced materials and their markets. Today, the company acts as an interface between the developers of innovative, sustainable materials and entities who wish to learn about and strategically apply them. Material Driven takes on educational, curatorial, and consulting projects for clients as diverse as developers, architectural studios, universities, museums, FMCG product brands, and trade events. Taking today, there was we closed with the conversation and with the debate on what the architects need to do and how we can be innovating, we can be there at that junction when we actually interact with the industry. So I think and you know we the industry is looking for people like us who can kind of tell them what to do with the product and really be in the product space also. And he was talking about certification, like Sushant School of Art and Architecture can talk about certification. So yeah,
absolutely. Actually, you kind of named it. That's probably quite early on in the presentation. I really want to touch upon exactly what you said. So I couldn't agree more. Yeah.
So basically, I think we are going to have it's like you know, a very seamless narrative. And over to you, Purva.
Perfect.
Amrita, she's going to present herself, it seems.
I know, I just put those back because the recording hadn't started while you were introducing her. So, so just
some things always get missed.
On record, that's all, so that Purva's introduction doesn't get missed.
Well, let me know. I'll try and present right now. Let me know if actually, one second. Give me a moment. Yes, perfect. Sorry, guys. All right. Actually, I am going to go ahead and share. Let me know if everyone can see the presentation. Are you guys able to see this?
Yeah, it's coming. It's
perfect.
Yeah.
And it's full screen for you guys. Let me know if it's not. Let me know.
No, we can see wait a minute. Yeah. Have you done full screen?
Yes, I have. Hopefully you guys can see it.
It's disappeared.
It's a black. Now?
It's disappeared.
Sorry, guys. How about now?
Yeah, it's back.
Yeah. Now you can see it. Yeah, I think it's an Adobe and Chrome glitch. I'm still pretty close to full screen. Hopefully this will do the trick. If at any moment, if you guys are having some trouble seeing my screen, go ahead and, I think unmute yourself. Everyone, please, say something. And if on the off chance that I get disconnected, guys, I would like to put a disclaimer. I have 3 devices on standby. I'll just disconnect and join from another device. So with internet connections, you have to put that disclaimer. But if you guys like, I'm ready to start. First of all, big thank you for having me here. As you said, I'm a Sushant alum, a very proud Sushant alum. And I'm the founder and partner at Material Driven, which is a design agency and materials library. I'll have a chance to tell you a little bit more about our work in a moment and kind of really break down what it is that we do, because it's sort of a niche field still, being an expert in materials, and a lot of people, including family members, will ask, what exactly is it that you do? So I'm going to tell you a little bit about our work in a minute, but I want to start this session by saying what the intention really is for this session. My hope is that I'll be able to suggest and trigger new ways of learning about, implementing, and teaching materials, and that you walk away from this session looking at materials as a very dynamic toolkit for yourself, a toolkit that you can use to solve the larger challenges that we're facing globally right now, and then a toolkit that you can employ for better design, better construction, and better habitation of spaces. So that's my intent. And I'll be pulling, as you guys really wonderfully introduced, I'll be pulling from our experience in research, industry, and education. And hopefully all of that kind of experience pulls into something that you can take away from this session. This is us, as I mentioned, material driven. I started the company in 2016 after practicing in architecture and landscape architecture for a few years. I started it in the US and then migrated to the UK, where I met my business partner, Adele Orkahada. Together, we've really evolved what it is that the company does, and we operate in the US, UK, and Spain, though projects, of course, take us to more exciting and diverse locations as well. Hopefully you guys are seeing the slides moving through as I'm moving. Let me know if you're not. You can see the slides moving, right?
We can see. We can see.
Perfect. Also, we're a design agency and materials library. And what does that mean? That means that we're the interface between the developers of sustainable cutting edge materials on the one hand, and on the other hand, it's the entities who want to use them or strategically apply them in their projects or even learn about them. And those entities, the material developers, can really be a very diverse mix of people. So they can be solo makers, they can be artists, they can be startups, and they can be large manufacturers. And I think that's a USP for us, that we really work with people developing materials at all scales, and we want to play a role in their advancement and bringing those materials to market. So we're not taking ready-made kind of really materials that are sort of off the shelf. We do work with a lot of people who are somewhere in that journey, and we like to play a role in their advancement. As the intro says, there's 3 dimensions to our work: education, curation, and consulting. And I'll very quickly just show you guys some images of each one of those. On the education side, we engage with universities, museums, research bodies, and nonprofits. And the output of our work can be, as you can see in the pictures here, they can involve hands-on making workshops, they can involve lectures, trainings. Sometimes we set up really exciting industry projects for universities using our connections with manufacturers and brands. So it's a really exciting realm. And then very often, and this is something that's happened a lot for us in the last year, we get called to be part of sustainability awards programs or grants. So we are able to, based off of this experience and network that we've built, we are kind of called in to help decide who's a good entity really to receive a grant, or who's someone who could really scale up their innovation. So there's a couple of different groups, like the Katorva program that we just recently became a part of. And it's an exciting realm. We're involved with research projects, and I think that kind of encapsulates what we've done on the education front. On the left, this is an image from a workshop that we did on biomaterials at the Design Museum in London. In the middle, it's a 3-day design sprint that we did for a university in the UK called UCA. And on the right, you can see students really getting their hands dirty. They're making I would say a simpler cement using natural fibrous wastes. So the second dimension of our work is curation, and that essentially means we pull from our internal library of materials that we have, which is about 400 plus materials and constantly growing. And then we pull from this large network of material makers who we've come to work with over the last few years. And we pull from all of those to create large-scale materials exhibits, immersive installations and displays. And we're almost always trying to tackle a very pertinent theme. So, it could be about resiliency, it could be about sensory design, it could be about decoding the term sustainability. We pick a theme, and usually our exhibits are, try to capture that. We tend to work with clients as diverse as museums, trade shows such as Architect at Work, who we've really loved working with for the last few years. And then also often architectural studios will put up small exhibitions within their studios to educate, especially the larger offices will sometimes do that to engage their staff members. So this is kind of the spectrum that we cover on the curatorial side. I do want to say, when you think of materials exhibitions, we tend to think of plinths and materials plonked on them. I hope that you'll be challenged in that perception today, because we really had the pleasure of working on materials exhibits that are not that. We got to work on this incredible geodesic dome of materials for the Baltic Center in 2018. And we actually worked with 50 material manufacturers and startups on this. And the goal was that every material or every huge triangle in this geodesic dome, which is about 7 meters wide, had to represent northern UK. So fun fact here, the northern part of UK is where the Industrial Revolution started. So all the way back to its Industrial Revolution history to now the place where graphene is being developed. It's a very exciting place, and they wanted to show that, but through materials and through domes. So it was a really fun project, and I wanted to kind of open you guys' eyes up to the idea that maybe materials don't have to look like little swatches on plinths. We can do fun things with them. And then almost always, really, our intention is that these exhibits, wherever they are, whether they're in a museum or they're in a trade show.
Aditi Gupta, stop presenting.
Oh,
yeah, Purva, you might need to rejoin.
Got it.
Yeah.
Let me do that.
It's there. It's there.
It's there? Okay, yeah. Perfect, lovely. Well, I think, yes, are you guys able to see the screen?
I think you need to rejoin, Purva. I think there's some.
Yeah. We can see the screen. Okay.
Let me do that. Let me resume. How about that? Resume presenting. How about that? Now you guys can see it?
Yeah.
Okay, yes. Right. Now everyone can see it?
Yes.
Yes.
Okay, lovely. So where did I lose you guys? Did you guys catch this dome, or did I?
Yeah, we did. We did.
Okay, perfect, lovely. Well, I think, yes, actually it's a good moment to kind of close the curatorial chapter. The intention really that we have is that all these wonderful materials, whether they're in people's workshops or they're in factories right now, that they come into the public realm, and people who can really use and push these materials through application are able to access them. And that's always the intention that we have with our exhibits. This is another project. We've done some work with 100% Design. It's a fairly well-known show. And again, the goal is to really challenge kind of existing models of display and get people picking materials up, thinking, lifting them. We don't, aside from a few fragile pieces, the goal is that everybody can come pick something up, take pictures, imagine it, maybe even make a little sketch about what they want to do with that material. So it's usually very interactive. And then finally, sort of our bread and butter as an organization is the consulting side of our work. And here, we've had the pleasure of working with such a diverse group of companies. It can range from consumer goods companies, cleaning product companies, hotel chains, developers, architectural studios. It's really a diverse group. And each time we work with a different type of client, we learn so much. On this page alone, you can see we worked with a sustainable bottle manufacturer, Ocean Bottle. In the center, we worked with UK's largest producer of cleaning products, stuff like Lysol. And then also, bath gels, which you can see here. And then on the right, we worked with the Woolmark company on a sustainability challenge that they created with Adidas. So in all of these different scenarios, there is some common ground. And clients, there is some common ground, and we're always asked to come in and suggest and guide these companies to better materials for their products, for their packaging, and for their spaces. We come in as that intermediary. We help them with research, with trends and competitor analysis. We guide them to better sourcing. And a growing dimension of our work really is that we lead these companies from concept to delivery. And that means we kind of become a project manager, where if a company wants to transform their product entirely, we'll guide them from the design phases to the production, to the fabrication, to the delivery to the end user. And I think that's a really exciting realm for us. And that kind of puts us as a sort of project manager in many ways. And that's what we're starting to do. The output can be really diverse. As I mentioned, it can look like on the left here, this is a sourcing exercise where we responded to a brief and we put together like 20 materials that responded to an architectural studio's brief. And then on the right, you can see is what we call our macro trend studies. And very often people will come to us and they'll say, we'd like to see what the next 5 or 10 years looks like in our industry. Can you look at macro trends in our and can you see how materials relate to that? So again, that's a really fun dimension of our work. It's very, it puts us into diverse, research areas, and we grow each time we learn about these new industries. But it always ties back to this idea of materials and materials as a tool to address the challenges for that client or solution or context. And then finally, this is a really, I would say, a really wonderful type of project that we did last year. We worked with a developer called OTO Development. They're one of the larger hospitality developers here in the US. And we worked with them on the AC Hotel by Marriott in Washington, DC. And the client actually who, I just so applaud them for being so open-minded and excited about materials. They wanted us to create art installations and three-dimensional kind of art/architecture moments all around the building that focused on exciting materials. That was the brief for us. So we worked with 4 to 5 different artists, fabricators, and material developers to create these moments. One of them is this light installation that you see here on my screen. It's actually just a huge flowing river of light. It's made out of handmade paper and optic fibers. And we worked with an artist studio called Lichtpapier out of Germany. And that's their USP, to weave optic fibers into handmade paper. So again, just a really exciting brief here. These are some of the other kind of three-dimensional art moments, again, focused on materials in the rest of the hotel. That's the check-in desk on the right. And I'll show you guys a close-up in a minute so you can see really what those little pixels or reflected pieces looks like. On the left is another very graphic artwork that's also highly functional. It's made from wool felt. And this is what those 2 artworks that you saw on the previous page, this is what they look like. On the left is the wool felt. So this was a very tactile artwork. The goal wasn't that people have to stay away from it. The goal was that people can walk by and even like run their fingers through it. It's very soothing.
A request, please go slower is the request.
Oh, all right, cool. I was so worried that I'm going to run out of time, but I will go.
This is standard Purva, if you let me say this.
Yes,
but go slower, Purva.
Yes, here is the professor's feedback and noted. Perfect. All right. So yeah, actually on the left, I'll actually go back a moment. But if you look on the left and on the right here, these are other moments kind of in the building. As I mentioned before, the idea was to really play up the materials element in them. These are moments in the building that are somewhere between art and architecture. They're permanent, they're three-dimensional, they're also sculptural, and we really worked with specialists in this field. So the artists that we work with on the left, they create acoustic paneling with very, very 3D wool felt shapes. So the panel on the left, not only was it really tactile and inviting, it was also highly functional, and it was placed in a very heavy traffic corridor. So they actually needed to muffle the sound and have something exciting. And then on the right is the work by the artist studio I mentioned, Giles Miller Studio. We got them to use their very signature tile unit, which is, it's a tile called the Alexander tile. And what they do is they play with the individual geometry of tiles and their orientation to create these sort of hidden graphics and optical illusions. So it was so fun to work with these different specialists. They all have an artistic or a material medium, and we played those up to execute what the client needed. So I think that sort of captures some of the work that we've done in the last few years. We've had the pleasure to work with some very diverse entities here. This is just some of them, but you can see they're kind of museums, brands, and it's been great so far. Lots of diverse kind of entities that we worked with now. All right, so I'm going to stop with that introduction. Hopefully you guys have some more context on what it is that we do. And I'm going to return back to what our intention is for this session. And I'm actually going to go one slide ahead, and I'm going to share what I hope are the 3 goals for this session. The first, I think, is tying into, and actually this goes really well with what Aruna said. It's understanding this sort of new landscape of materials. And as architects and designers, or future architects and designers, your students or apprentices in your firm, or younger, I think fresh graduates, understanding that there are new paths and roles for you, and there's a whole host of new players for you to engage with. So I want to do that. I want to kind of rejig that landscape in your mind. And then my second goal, really, which is probably the most fun part of the presentation, so I urge you to hang in there for this. The second part is identifying the really core themes and trends that we're seeing today in the world of materials and in the building technologies and fabrication realm. So I think, like I said, that'll be probably the most fun. There's some really cool examples in there, things you can directly plant into your projects, or you'd like to research maybe more after this presentation. And then finally, the last dimension is redefining sustainability. And having gone through the first 2 parts of this presentation, I really want us to look again at what sustainability can mean. And if we can kind of break it down in a way that is digestible and directly implementable, because sustainability tends to be a very loaded term in our field. Great. So if you're seeing the screen and you can see this diagram that I've got here, it kind of calls out, it's a generalization, to be honest, but I think as architects and designers, we tend to be pigeonholed into a very linear process. So we look at a pre-qualified sort of selection of materials, things that meet some basic criteria. We learn about these materials through our own education, through third-party resources, online, through vendors that come to our studios. We learn about them, we specify them, they get deployed into construction. Maybe the contractors and consultants have some back and forth with us on them. They get deployed in projects, and then the projects go to the end of life. It's a single directional process. Instead, I would like you to consider this very, it may look complex at first, but I'd like you to consider a more flowing, kind of a diagram that represents both the direction that this reality is now moving in and a preferred reality for us as architects and designers. The first thing I think that you'll notice is different about this diagram versus what is before is that the architects and designers are engaging with a whole host of different entities. So you're not just dealing with 1 or 2 different types of people. You're interacting with material manufacturers, solo makers, artists, scientists, researchers, libraries, policymakers, certification agencies, as Aruna said, special interest groups, non-profits. Architects and designers are most highly placed. I think they're the best positioned really to become that bridge between all of the developers and the certifiers and then the implementation. And I think architects and designers have to widen that net. The second thing is, it does not have to be a linear process, so that the manufacturers create something perfect, hand it over to the architects, they specify it, and then it follows through. Instead, we as design professionals are uniquely poised to say, hey, why don't we use this amazing material? It's kind of being produced at a small scale right now, but we've got a perfect project for it. Let's apply it in our project, and it will give the opportunity for the production to scale up, for it to have some testing, some certification, for it to have some metrics. It has to be a feedback process. So we take on the role of testing in a way. We feedback and say, hey, this is what we found in our project. We help the manufacturers and the designers of these materials to actually evolve their offering. And I think that's something that we have to consider. The other thing is on the specification end. No longer can we kind of say, hey, specification depends on project, on cost, on a few limited factors. It has to consider a broader circular economy, the communities who are going to gain from it, the end of life, and the education side. Like we're uniquely poised between client and manufacturer, we're also uniquely poised between education about these projects and the materials. So I think the biggest difference for me really in this diagram is understanding that architects and designers are at the core of a constantly flowing loop. And we can take a very dynamic role in this equation. We can forward so many innovations because we have the ability to do that. We just have to open ourselves up to more entities and give some innovations a chance. So I'm just zooming in a little bit here in case you guys missed some of the terms before. As I said, I think that whole span on the left is so valuable to think about. And then on the right, I do want to say one other thing that distinguishes this reality from the previous one. And that is, invariably when we specify materials on a project, that's it. But what happens if we consider all the waste that's being generated at our client sites, at our project sites, construction sites, at the end of life, and we continue to maintain the relationship with these manufacturers and material developers, and all of that project waste actually feeds back again to the players into the making of new materials. And I think, again, we're at that perfect junction. We're in a dynamic role, and I think it would be nice if we start to think of ourselves in that way. So you will notice that I use the word material maker a lot. And the reason I do that is that we believe this is a very distinct and new type of entity, a very unique entity and an emerging entity in the design industry today. Based off of our multiple experiences with researchers, with solo makers, designers, this is a sort of, a three-line sort of definition that we've come up with. And I think one thing that stands out about this definition, really, if you had one takeaway, it would be that material makers today are working across disciplines and between disciplines. So they tend to be groups of designers, scientists, engineers, artists even, and that diversity of experience and talent is driving some of the most exciting materials today. And then I would say the fact that many of the most promising materials today are kind of throwing out the norms on previous products. So they're looking at established entities and precedents, and they're saying, we don't have to necessarily fall into that bracket. And I'll show you guys examples shortly. On this screen, in fact, we have a really interesting example. It's a product from a company called Biomason. Biomason's brick is called BioLith, and what they've done is that they've done away with the curing and cementation of bricks altogether. What they do is that in a mold, they place aggregate and sand, and they put in bacteria, living bacteria, and it's the bacteria that produces the cementitious material and hardens and forms the brick. So essentially, you're left with a brick that was biologically created. It's a brick that's as strong as concrete counterparts, strong enough to be used in facades, in load-bearing ways, but its carbon footprint is I think it's less than 1% of a traditional concrete brick, because you've done away with the high temperatures needed to cure these bricks. You've done away with the curing, the furnaces, and that is such an exciting invention to me because, again, it's a wonderful group of people who are working on it. They're a team of biologists, scientists, engineers, and specifiers who have developed this material. So it really represents that ethos. This is what a young startup working in the materials space actually thinks of themselves. Chips Board is a company that started out with the intention to replace MDF. They felt MDF is, loaded with toxins. It's hard to recycle, and they said, how can we look to alternative sources of raw materials and create something that has most of the properties of chipboard. Chips Board is their play on that. So they actually worked with the frozen foods company McCain, who had vast amounts of potato peel waste. You can think about the chips that we have from McCain, the Smileys, all of those frozen products. Just imagine the massive scale of potato waste that they're generating, which interestingly is very high in starch and can be converted into a material that is as strong as a sort of plywood in some ways. And it's shown here on the left. I will say the company is in the very early stages of scaling up, so you still can't buy a huge sheet of it. But the premise is really interesting, and I think what they say about rejecting the norms is really crucial to some of that material maker mindset. This is a good example, I think, again, of somebody who has achieved great scale and innovation while creating a very exciting cutting-edge material, and they've done it by challenging what a pre-existing material could be. So Connor is the creator of Foreso. The material was launched 3 years ago. It's already in massive production. They have their own production plant. The materials are shipped all over the world, and interestingly, it's almost entirely a waste-based material. So it uses plaster waste, it uses sawdust, wood chips, and a bioresin. And as you can tell, it is a take on traditional terrazzo because it's wood terrazzo. And I think, again, it embodies that mindset that we see companies of all scales who are either reinventing materials, pulling from tradition, or pulling, kind of really reinventing the wheel on certain existing products, but they're generating some really exciting and promising solutions. And they find that they can material making gives them a certain creative license at this point. So the second type of entity I want to mention in this context, aside from the material maker, is research. People, entities who are engaged in research. So it could be research groups or individual projects or special interest groups, and then facilitators. Material libraries, I have this on here purely because we work as a material library, and this is how I know we're able to create impact. I think whether you are a university or you're a design firm, whether you have a library that you've created inside of your institution or your office, or whether this is something that you access sporadically, it is such a tremendous resource that we must regularly pull into our work. For one, for students especially, it's such a tool for hands-on making and learning, object-based learning. And more than anything else, it's not just a collection of samples, it is a path to interacting with the industry, especially for students. It's so valuable. It's a training ground. And I think one thing that universities tend to think about material libraries is that they're going to become a kind of repository of exciting products from outside of the university. That does not have to be true. In fact, material libraries should actually become archives of all of the interesting materials or manipulations of materials that their own students are making. So think about it. I think it's an exciting way to think about material libraries as a resource. You're obviously pulling in knowledge and physical samples from outside, but you're also documenting in that library all the innovation that is happening within the walls of a campus or an office, or all the edits that you've made to existing materials, or tweaks or customizations, even if students or professionals have not actually invented materials themselves. So just want you guys to think about this entity or tool to engage with. And of course, libraries can be can come in so many different shapes and sizes. On the left is an institutional library that's only accessible by students. The Institute of Making is very well known. In the center is Material Connection. Many of them know them. They're a behemoth. We have so much respect for them. They tend to work with some of the largest, I would say, brands, consumer goods brands, and they're open only to their clients. On the right is someone like us. We're a little guy. Our library comes out to the public at strategic moments, whether it's exhibitions or sessions or to clients. But I would say it's a blend between the two on the left, because it is publicly accessible, but it is also targeted to clients. So lots of different shapes and sizes, and lots of ways in which you can build your own library, both at a firm or a university. And then I think finally, I won't spend too much time here, but I want you to consider this idea of getting involved with research projects and enterprises. It may feel at first glance that getting involved with a research project on materials there's no direct financial reward. There's no clear outcomes, especially as a university or an industry partner if you're an architectural firm. But it is such a wonderful chance to have a front seat to all of the innovation that you're going to see emerge in the next 5 years. It gives you such a brilliant window into that. Of course, anybody on your teams, whether it's professors or practitioners, you develop an in-house expertise if you come on board these projects as advisors or industry partners. So you're growing your knowledge pool, and you may find that involvement with, whether it's a national project or an international research project, you may find that it sparks new sub-courses at the university, or sub-courses or short programs at an architectural firm. So I think I do want to say that this is a very interesting realm that we don't talk a lot about. And the two projects that I've got here on the screen are the two research projects that we are involved with. The first we are advisors on, and on the second we're known as industry partners. And the first actually is a project that combines microbial biology with architecture to create living building elements. And the second is an excellent tool. I urge you to look it up. It's called Endure, developed by the universities of Newcastle and Loughborough. And they are looking at material aging. So how can you, before you choose a material, how can you predict its aging and have a better worldview into what that material will look like? Great. So everyone with me? Everyone with me so far, seeing the screen and doing okay?
Absolutely.
Yes.
Great.
There are questions also coming in, but what we will do is we'll take them afterwards, and we'll just chat afterwards, and then if you want, we can go back.
Perfect. Yeah, that sounds good to me. That sounds good.
Okay.
Great. Perfect. All right. So like I said, guys, this was the most fun part. I hope you've held on till now. This is definitely the more interesting part, looking at themes and trends. And many of these will relate to something that you're doing, a goal that you have on a project, or something that you're reading about, something maybe as professors, this is part of your focus or your kind of research interest. So we'll touch upon a few key themes today. The first will be in the materials world, and the second more towards building technology and fabrication. So bio-based and living materials, we're hearing a lot about this. I think I'd like to define living materials as materials that have used living kind of raw materials like algae, yeast, fungi, bacteria, even viruses, and then bio-based materials that pull from natural raw materials or natural wastes. Especially, there's a lot of interest right now in natural cellulose as an exciting material, and I think that's kind of a good way to define what I think of right now as bio-based and living materials. And of course, as we've seen, the outcomes can really vary from bricks to textiles. You'll see a diversity here. So the first, I think, is a good example of a living and bio-based material. This is a company called Mogu. They're in Italy, and they are probably one of the leaders in mycelium-based technologies. They have managed to create these acoustic panels using mycelium, which is the vegetative root of mushrooms or fungi. And as you can see right here, there's some beautiful geometry, complex shapes and detailing. So in no way would you, as a client, if you were a client, you wouldn't feel that the material is kind of falling short in some capacity. And yet this material has been grown in a vat, in a mold, and it's been created using textile waste and mycelium. So I think it's a really interesting way to look at materials now, because this is a material that matches the acoustic and fire retardant properties that we need for interior wall paneling. It meets all the sound absorption criteria, and yet at the end of its life, it can be biodegraded. So really kind of opening our eyes to all the possibilities there, very specifiable, lots of shapes and sizes, something to think about. Um, Now, I mentioned cellulose before. I think if you read a little bit about this, there's a lot of interest in this phenomena called structural color. And it's a phenomena that you see a lot in beetle wings, in certain berries, in even butterfly wings. And there's a lot of researchers in the architecture and fashion sectors around the world, and they're looking at how structural color can be replicated in wood cellulose. So this is a group led by Noora Yao. She's a PhD researcher at Aalto University in Finland. And what that group of scientists, chemists, and biologists in the architecture school has figured out, really doing, is that they're able to manipulate the cellulose at a nano level, at the nanoparticle level. And by doing that, they're able to create the shimmering effect without any synthetic coating, without any addition. And that means that you've actually got the shimmer that you would expect from plastic, but you have it purely by manipulating what natural wood looks like. So it's such an exciting phenomena to think about, that manipulation at a living material scale is able to give us some really wonderful outcomes here. This is a project in some ways closer to home. Shneel Malik is an Indian designer and architect who is now at the BioID lab at UCL. And Shneel has created this wonderful tile module and larger facade system using those tiles. The tiles are made from natural clay. And then the green gel that you see in this photo right here, that's microalgae set in hydrogel. The hydrogel keeps it moist, and the goal really with these tiles and their assembly is the following: that if you were in an area where water is contaminated, and particularly if you don't have access to water cleaning tools, water flows through these tiles, and the microalgae really just capture and hold on to those contaminants, and they draw the toxins away. So it's such a great resource. It's using living materials, the microalgae. It's using natural clay. The whole assembly of tiles is biodegradable, and yet it's a very low-cost solution to a very large problem, which is contaminated water. So I want to move on to a second section here, which is sensory materials. I think these are materials that are designed to engage with all of our senses, to provoke us to interact and engage with them. And increasingly, you guys will echo my thoughts here. The goal for some of these materials is to provide us relief. Our world is so increasingly digital. We need a break from that digital realm with tactile materials, with materials that help us feel like we're connected to interesting surfaces, that challenge us, playful materials. And I think this kind of represents that category. This is Happy Concrete by a Dutch designer called Ivan Pol. As you can see, this looks nothing like the concrete that we imagine. It's colorful, it's textured, it's patterned, and that's exactly what he does. He wants you to get tricked and for you to reach out to touch this thinking it's sponge, but in reality it is concrete. And the tiles that he creates can be used on wall surfaces. He also has flat versions that can be used for flooring. And again, really representative of that idea of creating a reaction, engagement, tactile kind of engagement with people. You saw these tiles in one of our projects. They are the ceramic and timber tiles. And Giles Miller Studio, who create these tiles, really use them to generate a few different effects. They mix these materials a lot, and they'll do this so that people experience optical illusions, engagement, they see various reflections, they invite touch. And it's really using some very simple materials like ceramics, timber, metal glazing in a really advantageous way, where material and geometry come together in a very sensory output. I don't know about you all, but I have a real fascination with silicon. I find it such a relaxing sort of, spongy material. And this is something that Hannah Williams Studio has picked up on. She uses a marbling technique to create a very interesting visual effect, and she combines this marble silicon with waste carpet tiles to create a very nice flooring material. It can also be used for wall paneling, for furniture, etc. Very versatile, and yet she's kept some of the exciting properties of silicon intact, which include being extremely heat proof and being antibacterial. And then kind of really shattering what we think that wallpaper or wall covering should look like. Alyssa and Yenka are a Dutch studio, and they've really challenged this idea that we have of smooth and two-dimensional wall coverings. Instead, they want surfaces made of paper and textiles that move as people enter a room. When there's air movement in the room, the wallpaper sways and interacts. And I think kind of goes back to that idea that we can really play with materials if the goal is to engage with the senses. So this, I think this couldn't be more relevant to us all. If one is grown up in Delhi, then you know that pollution is, pre-COVID, one of our biggest challenges. COVID is a whole another chapter now, of course. But pollution absorbing materials are really of interest right now, as are carbon negative materials. And these are materials that either through their manufacture or use are actively pulling carbon away from the environment, and they're sequestering it. So this is just such a growing and exciting realm. And made of air is a material from Elegant Embellishments that really embodies what these materials are out to do. So what these guys really do is that they burn biomass, but in an airtight environment. It's called pyrolysis. And the soot that's captured from that process is bound with a biobinder to create a thermoplastic. The thermoplastic is cast into these facade panels, which are resilient and robust, but at the end of their life, they can be composted again. So really representative of the idea that pollution or carbon that would have entered the environment is now on your facade, and it's being used, and at the end of its life, it'll return to the earth, never to go back into the atmosphere again. And you've managed to create a really highly functional product out of it. Carbon Craft Design, Bombay-based studio. These guys, of course, again, working with that captured soot, but instead they work with the soot that Gravity Labs collects. Gravity Labs are the wonderful folks who've created Air Ink. And actually, we're excited to be working with them right now on something fun that will concern all of the talented creatives and designers in India right now. But essentially, what Carbon Craft has done slightly differently than Made of Air is that they've used that captured pollution, whether it was extracted from the exhaust pipes or from factory exhaust pipes or car exhaust pipes. They've turned that soot into a dyeing or coloring agent for their cement tiles, and the tiles meet the criteria of other cement tiles. In every regard, they're highly potent. They're very good on all the technical metrics, but with a very unique aesthetic that is representative of a particular city's pollution. So great narrative, good functionality. And then I think this is a very versatile material to consider when you think about pollution. Anemotech have developed a fabric called the Breath. It's a 3-layered fabric. The outer 2 layers can be printed upon, and the inner layer is made out of carbon nanofibers. And essentially what this fabric does is that it captures indoor and outdoor air pollution, VOCs, toxins, and it traps them within the carbon nanofiber layer. But since the outer layers can be printed upon, this fabric can be used in a number of ways. You can use it for hoardings. You can use it for indoor signage, art, as you can see in the picture on the right. And it's just essentially such a versatile and functional material. And I think I don't have the metrics right here, but they have a per square meter metric. So in indoor environments, 1 meter of this fabric captures X amount of pollution. In outdoor environments, there's a slightly different variation, but it's very scientific and yet very versatile from a design perspective. And then another interesting example of attacking the problem of pollution. So this is a project by Poppy Pippin, who's a UK-based designer, and she's actually working with a very simple material, which is terracotta tiles. But the grooving pattern that she's cast into the terracotta tiles invites the growth of moss. Moss, in turn, is excellent at capturing carbon dioxide, and by doing that, the overall air quality is really improved. So these tiles can be used in indoor, outdoor spaces, facades, streets, in a number of different ways. Again, simple moves using simple materials. Moving on to materials for health and well-being, I want to say that materials for health and well-being can operate in two ways. They can go in one direction, where they prevent us from coming in contact with toxins and damaging materials that can harm our health, or they can actively contribute to our contact with positive sensations. So maybe bringing us closer to nature or providing a sensory relief. So there's two different paths you can go. This is a wonderful paint. It's comparatively priced out in the world. So it's a white paint that is priced like other white paint. But the composition of this paint is incredible. It's a combination of lime and graphene. And that combination allows the paint to last really, really long. And through the process of its life, through the course of its lifetime, continue to absorb carbon dioxide from the air and toxins as well. So simple move, just paint, but you can make such a good, you can make so much impact with just paint. All right, everyone still with me?
Yes, ma'am.
Perfect. Gotta keep checking.
Yes, we all are here.
Great. Great. All right. So speaking of bringing us closer to nature, as I said, there's another path that you can go. Organide is, I think at this point, they're kind of well known. They've been around for about 10 years or so, but such a great example of how you can feel closer to nature in a very basic material. So actually they work with seeds, leaves, hay, flowers, coffee beans. They take all of these natural waste products and they combine them with a bio binder to create these wall coverings. And I think the USP is, of course, the aesthetic, but it's the smell which really makes this material stand out. If you come close to it, not only do you not smell any chemical coating or anything synthetic, but you're actually able to smell all of those things. You smell the wheat grain, you smell the hay, you smell the coffee beans. And if you've had this material on your wall for about 2 or 3 years and if they lose their scent, you're encouraged to spray water on them and the scents are reactivated. So it's just such a great material and a simple way to help us, especially in this time where we can't step out so much. Why not bring us closer to all those things in the outside world that give us relief and a sense of well-being? And there are materials that do that. Very quickly going to go over this one. So this is a Swedish company called Box. And I think what they've done a great job of doing is creating a very functional, highly acoustic material using I think pretty much like 100% natural waste ingredients. So they use wood waste, fruit peel waste, and on the left-hand side of my screen, you can see all the waste products that go into making these panels. The panels are naturally fire retardant. They have excellent acoustic properties. You can see the geometry is pristine. So it's a very finessed and, true to Swedish design, I'm sure, like very, very cutting edge product, but natural waste materials. And when you're looking at them, you actually do feel a sense of being in contact with something deeply natural. In fact, if you look carefully at the screen, you'll notice that there's a color variation from the left to the right. The panel on the left is pure white, and the one on the right is kind of in the coffee beige category. But there is no coloring in there. The panel on the right just has more wheat bran in it. So they've used wheat bran as a coloring agent here, just like pure wheat bran, and which is why the material has a greater tendency to create a sense of well-being. In fact, they did a test where they put it out in the forest, and apparently the materials, even like forest creatures responded as though this was something natural, which is why this photograph is there in the presentation. Now, when we think of well-being, many of you may think of soft surfaces. We think of the softest cotton t-shirt that we own, right? A comfortable cotton t-shirt. Why not create a material that has that sensation? Why not take that soft cotton t-shirt and transform it into an acoustic material that we use in our space? That may have been the intention for Milforma. And Milforma have created these wonderful acoustic panels with natural dyes. And the base material here is cotton lint and clay. Highly natural. If you touch it, you do feel like you're touching your softest cotton t-shirt, and yet nowhere is this material falling short in functionality, specifications, sizes. Pricing, yes, there may be a slight uptick. That's something that we're seeing right now with some of the cutting edge materials, but I think it's really worth it to create those impacts that we're after. Kind of moving on to energy and resource efficient materials. This is such a core theme for us right now, whether we have to be conscious of the raw materials we're sourcing or the energy we use for manufacturing. I want you guys to look at this wonderful example of Finite. What they're really doing is, instead of using river sand, which, as we all know, gets heavily used in all building construction, they are shifting the focus to desert sand, because river sand is getting depleted at a very rapid rate, whereas desert sand, which is very fine in texture, is rarely used. So they've come up with a way to convert desert sand using bacterial binder, a bio binder, a combination of these two, and turn it into a material that is quite concrete-like or cement-like. And I would say very early stage, yes, at the moment. However, the intention really is to completely remove our dependency on river sand, which is being depleted fast. This is a nice way to think about our concrete. What if all the concrete in our buildings was generating energy? This is what Discrete is doing. The concrete is embedded with solar activated dyes, and the solar activated dyed cells in there have a photochemical reaction when they hit sunlight, and energy is generated in electrodes that are embedded in the concrete. I have to say, I'm not 100% clear on the absolute technical workings of the concrete, but I do know that they have very good energy testing. They've managed to create some very, very large swaths of the material, and they have good metrics on how much energy has been generated and stored in batteries. So don't ask me too many questions about this one, guys. I'm not an engineer, but it's a good one. And then we all know this. I think in India, we understand how I think warding off heat gain is so valuable. And this is a studio called Unstudio in combination with a color company or a paint company called Monopole Colors, and they've developed the coolest white paint. Not only is the paint really resilient, where it lasts up to 30 years, it's corrosion resistant, but it also has a very, very, possibly the lowest of this category, TSR, and that means it's a total solar reflectance. So it's a very highly reflective white paint, it's very resilient, and the goal really is to reduce the heat island effect, and if you were to use this on large swaths of your building, you would see significant gains on the energy and heat gain front. Another idea of efficiency is also looking at materials and considering using very little of the material to get a large impact. Tesla Mendelovich are an Israel-based studio. They create these wooden textiles. They're essentially faceted veneered wood layered on top of textiles, and they use them to create wooden paneling on walls, space dividers, and even furniture. And I think the biggest USP really for them is, with a very, very small quantity of wood material, they're able to create load-bearing structures, and they achieve the strength that you would expect from a solid material, but it's usually created just from a very, very thin veneer, and they use the geometry of the cuts in the veneer to achieve this strength. So such a great way to think about efficiency. Why not use a tenth of the material that you would use were it a solid material and achieve some of the strength that we're looking for? Finally, in this category, waste-based materials. I think this is such a pertinent theme right now, whether it's industrial waste, municipal waste, or agricultural waste. We're seeing such an interest in products that really transform that waste. This is a designer out of the Netherlands, Agne, and she sources waste. It's highly contaminated metal waste that she sources from water purification plants and soil remediation plants. This waste is considered highly toxic, and yet Agne's research led her to understand that when you use that toxic waste as a glaze for ceramics, you end up with beautiful tiles and a color spectrum, but you also kill the toxicity of that contaminated material during the glazing and baking process. So she's found a wonderful way to do this. The tiles are being produced at a very large scale now and being used for architecture and interior design processes. And again, just points to the fact that even toxic waste is highly appealing and usable in the right context. Quick example of a brick that's made from 90% construction and demolition waste by Kenotic. It's really strong. If you are following the news, the Serpentine Pavilion this year in London was due to be made with this wonderful brick, but sadly, the COVID situation has delayed that. But look out for that. Hopefully next year or in a few months' time, the whole pavilion will be made with these 90% recycled waste bricks. And then I think we've all grown up seeing, mud or dung-based houses. This is a project being run by a studio in India and a studio in the Netherlands together. And they really want to explore two properties that natural dung has, which is, it's a waste product from the food industry. There's cow dung collected kind of in millions of tons in the Netherlands, where they're testing it out right now, as in India. And they found a way to really tap into two properties of dung. One, the fibrous nature of it and the strength that it has, and then two, the temperature regulating properties. So they're really trying to finesse the material and make it something marketable and usable. An exciting project there. All right, so everyone with me, we're going to move on to the next section, and this will be relatively quick.
Yep.
Great, perfect. Great. So I think we talked a little bit about materials. Now let's talk a little bit about, I would say, processes, technologies, fabrication techniques, and even like ideologies in some ways. One thing that we're really seeing from a manufacturing perspective or a building construction perspective is this idea that sourcing can happen from so many different sources, so many different industries, that there are overlaps right now where the food and agriculture industry is feeding into the construction industry, that there's so much potential there where the building and construction industry can pull from the raw materials and infrastructure that these other industries have, and we need to tap into these unconventional sourcing possibilities. So on the left, we have a brick, a really strong masonry brick that's made with rice husk ash. So when rice husks are burned, there's an ash that's created that actually has all the properties that Portland cement has. So that's a brick made with that. And then on the right is a beautiful I would say insulating foam material that's both decorative and functional, but it's a combination of eggshells and glass. So this idea that the food industry can become a new sourcing ground and even a manufacturing ground for us. Another example from the food industry, this is a material that tries to mimic the properties of MDF, but it's made from fish scales, which are a waste from the fish industry. And then kind of looking to this idea of other industries as a source for ideas and materials for us. And I think the science and technology sectors have always been appealing to us as architects. It's something that has always fascinated us. One such example, is metal forms. And metal forms were traditionally used as catalytic converters or energy transformers or heat exchangers, whereas now we're starting to see more and more buildings using these metal forms for an aesthetic purpose, but also to reduce weight, to provide a lightweight infill material, to create sandwich panels, to give us strength for less weight, and also to create these, beautiful textures that some of these very scientific materials offer us, but to deploy them in a facade application, for example. So I think interdisciplinary sourcing, particularly from from unconventional areas, holds a lot of promise right now. And then kind of the hot topic of the hour, computational design is always being talked about right now. But imagine the combination of computational or parametric design with exciting materials. It's such a tremendous combination because we see these materials, particularly some of the new natural or bio-based materials, being elevated to such a good space by using computational design. This is scaled by layer design, and it's actually a recycled hemp-based system. But by using this sort of spine or structure developed with computational design in mind, it's really a finessed solution now. It's turned into something that can be adapted, it can be rotated, moved. I think it's really expanded what could be achieved with those lightweight acoustic panels made out of hemp. An example of a simple material elevated with parametric design. So these are simple fir timber blocks, and they have been individually cut parametrically, thinking of parametric or computational design, and then their whole assembly together has been designed kind of at that computational level. And the result is that you have a wall that's incredible aesthetically and acoustically, and you've used a very, very simple material to achieve that. We hear this all the time, given what's happening around the world, this idea of designing for resilience, designing for change, adaptability, modularity. These are such core themes. But essentially what we want is we want to have materials that can deform and adapt to our needs, that can respond to these changing and unexpected circumstances. This is a good example of, I think, I would say an architectural textile. So Studio Sumira Boone works with really resilient textiles and then heat pressing technology that can be deployed on those textiles. She uses that to really play up what traditional origami techniques have to offer. But the result is she has these massive textiles that can be turned into textile architecture, as she calls it. So this kind of folded fabric that you see here, the way it's been pressed using heat pressing machines, and again, computationally in some ways, they can be deployed to create large or small space dividers. They can become more three-dimensional, they can be more 2D, but really they can serve multiple functions, and it's all a combination of materials and fabrication technology. And then I think the real bane that one of our biggest struggles right now is this idea of adhesives. I think you guys will share my frustration with this, but you will know that when you use MDF or when you use carpets, the reality is that the layers of these materials are so tightly stuck together that at the end of their life, these layers can never be separated. And when these layers can never be separated, these materials can never be recycled. So a company called DSM Nayaga has developed a glue like a screw. So remember that sentence, it'll stick with you, glue like a screw, where the recycler can trigger that adhesive to unwrap itself. And then on the left, you can see all of those layers, the veneer that we so need to use MDF materials or E-core panels in this case can be removed. The layers of a carpet can be dismantled. And I think it really points to this idea of technology and construction techniques at a material and spatial level that can guide us to better outcomes. And then lastly in this category is this idea of growth as manufacture. I think it's so important for us to consider that manufacturing may not look, doesn't have to look as we imagined it to be all this time. Growth can be a way of manufacturing bricks and mortar and all of these different objects that we use. And I can't think of a better example than this. So this is a living brick by the Living Materials Laboratory in Colorado. And this brick that you see right here on the screen can actually be sliced and reproduce. So by that I mean, if this brick was chopped in half and a little bit of sand was provided to those two halves, they would grow into a whole brick each. And that is possible because the ingredients of this brick are living. There is cyanobacteria in there, there is sand, and there's a hydrogel that's keeping everything alive. But it's this idea that we may have in the future, we may have the way to manufacture materials may be growth. It may be the reproduction of our bricks and mortar. So it's definitely a little out there, but it's something that as a technology and as a method of manufacture that we should embrace because surely in 5 to 10 years time, this could be a lot of our construction materials. And then speaking of growth, I don't think anything grows faster than green algae. We know this. We've looked at rivers, ponds, water bodies. They're choked with green algae. So a company called Algix in the US has actually found a wonderful way of capturing all of that, depolluting this fastly, this rapidly growing material from the water, saving, all of the plant and animal life in the water, but turning all of that gook, that algae gook that is collected into some really valuable materials. So they turn it into bio-based resins, and the resins can then be turned into foams or shoe soles. So there's actually a whole range of shoes out there right now by Adidas and Aviro that are being developed with the Algix soles. So there's algae in your sneakers coming up. All right, so a kind of final sort of dimension of the session is this idea of redefining sustainability. Heads up, there's only 2 slides coming up next, and then we'll go into an activity. So I just want to see everyone with me so far?
Yes, yes. Just a point that this activity that you are are showing is for our FacTOR participants.
Okay.
But if others want to engage in it, go ahead, do it. Yeah.
Okay, perfect. No, that's a good point. Yeah, I think maybe, I think, yeah, you guys can evaluate the outcomes, and you can, like, the kind of the faculty can take it more seriously, but everyone else can, kind of do this for fun as well. Yeah, that seems good. Great. All right. So, kind of considering all that you guys have, looked at so far, why don't we look at this idea of sustainability? We know that it's a very loaded term right now, right? It's so heavily contested. Everybody has a different opinion of what sustainability is or isn't. There's so much greenwashing. I want to add one more, notion to that mix. Hopefully it doesn't confuse you, but in fact, our hope is that it is a very, very simple explanation. The reality is, right now, doing less harm is no longer enough. And a lot of different entities in the design industry believe that the future of sustainability is regeneration. That means if your material or product or building is not in some way giving back more than what you've taken from the environment, you're not really meeting that sustainability goal. Regeneration is the way. So if you think about it, being a producer or creating something that the environment or communities can benefit from, that's regeneration, and therefore that is the new sustainability. On the right, you can see this spectrum, which I think really defines well to me where we are. Sustainability as we currently know it is actually just a point of neutrality. And frankly, it's quite low down in where we can be. We can be up there. We can be at the top of that green spectrum. We can be regenerative. We can actually be giving back to nature rather than pulling from it. And I think that can be the new definition of sustainability. I can't think of a material that defines regeneration more than mycelium. I know I've mentioned it once before in the presentation, but I want to reiterate why I think it is a regenerative material or a truly sustainable material. It's because mycelium grows on waste. It grows on scraps of any kind. It grows on food waste, wood shavings. It grows with very little energy and resources. It doesn't really need anything except the mold that you want to cast it in, and perhaps the ambient temperature that you want to generate, or watching over it periodically over time. It's not energy intensive, and yet the outcomes are structurally strong. They're naturally fire retardant. If you're interested in this, I really urge you to watch a short BBC documentary about mycelium, where they actually set fire to a brick of mycelium from the bottom, and on the top of that brick is an ice cream cone, and the ice cream cone does not melt, nor does the mycelium brick burn. So we have a material here that's so naturally I think sound from a technical perspective, and yet so low on resources. And the other promising quality to me that makes it truly regenerative is this idea that we're learning now that mycelium can consume and digest plastic. So not only can it grow on waste, it can actually feed off of the most unrecyclable waste that we have in the plastics department, and you can end up with something useful and functional. So just something to think about. Look into this idea of regeneration, and hopefully it is something that you guys can consider. So we have just something to ponder over. Takeaways and moves. What is it that you would like to take away from this? I think it's really valuable as architects, designers, and educators is that we think of ourselves as very dynamic players. So we don't have to see ourselves at the bottom of the chain where the products come to us when they're ready. We can be working a lot more directly with the makers, the manufacturers. We have the power to infect change in both directions, in the application and the manufacturing. I also think it's our responsibility to embrace the unsavory and unpleasant waste materials. And I can't think of a better example than these ceramic tiles that are glazed with urine. Yes, I said urine, guys. Before, in previous years, for centuries, urine has been used to dye leather in tanneries, and it's actually a very valuable material from a chemicals perspective. It's just this idea, it's symbolic of a concept that we as, again, architects, designers, and educators, we can shift people's perceptions and turn the unsavory into something valuable. And then, of course, like we said before, this idea of incorporating hands-on making can be really important, and then also pulling from really diverse industries. I think there's some real opportunities for us, for you as faculty, for you as practitioners. There's so much possibility there. And okay, I'm going to stop here. If you guys actually, Amrita, Aruna, would you guys like me to pause and answer questions and then we do the activity?
Yeah, sure.
I think
Let's
that's a
do
great
that.
idea. And Purva, there's lots of questions which have been placed in the chat box.
Okay, great.
I think,
right, I'm back. Good.
We would leave people to ask the questions because
Okay.
it's difficult for us to go through all of them.
Yes.
Let me just sum up a little bit. There are questions about lifespan,
Yes.
evaluation.
Yes.
There are questions about application of materials for internal and external situations. There is, there are some questions about how to innovate in traditional with traditional materials, similar sort of innovations. Questions about behavior, moisture tolerance,
right.
costs, and applicability. Lots of questions.
So everything basically.
Yes.
All that you can think about. No, but I think very, very good questions, because the reality is these are wonderful ideas, but until we can't actually put them in the hands of contractors and clients, they don't have that as much power. I'm going to answer kind of the first question is, I would say that of the materials that you saw in this presentation, it's about 60% materials that are already commercially viable, that they're out there in the market. And then about 40% materials are in the advanced startup stage. So that means they have funding, they've got prototypes out there, and they've done small test cases. But about 60% of them are able to ship out materials to projects, albeit small to medium projects. Some of them, of course, are rolling out in the thousands, and they can meet the capabilities of like plywood, etc. I think you mentioned price. Yes, it's a I will say without a doubt, most of these materials are slightly higher priced. If I would say they're about 110%. So it's like a 10% up margin from regularly priced materials. Yes, you will probably have to haggle with your client. You will probably have to convince them. None of these products are either below par of their counterparts. So if you're looking for I don't know, a brick from Biomason, it's not going to be cheaper than another concrete brick. But there is, it's kind of that moment. I think that kind of goes back to that role that we have as architects and designers. It's our job to push the client and say, if you sign up to do this, by next year, the prices are going to drop. I think there is a very, very strong role that we have in scaling up an implementation, because the more these materials are used, the prices will drop. And then who knows, in 4 years' time, there won't be that 10% uptick. But yes, all of them are without a doubt slightly more costly than their traditional counterparts. Yeah, I would say that.
Yeah.
There were some other questions. I missed a lot of them.
Application, internal, external. A lot of your materials seem to be purely for internal application. A lot of these materials, very few you mentioned external application. So
there's plenty in here. I would say Biomason, the Ignorance is Bliss tiles, the Kenotech bricks. In fact, a lot of these are intended for external application. And I think it comes back to that idea of waterproofing as well. Some of these materials are offered with the additional possibility of having a synthetic waterproof coating, which makes them more resilient. It may inhibit the biodegradability a little bit, but almost even the materials that are selected for internal use and they're made from things like mycelium, there is the ability to put a synthetic coating on them and make them eligible for outdoor applications. I would say maybe about 50% of these materials are outdoor friendly. They are. Yeah.
So I don't know, this is not a question there, but this is me butting in. I mean, as you know, I mean, maybe at some point you could also tell us about how the process of application into the built environment actually takes place, what it takes, because over here we are talking about introducing ideas of this kind into our teaching, right? So
yes.
One is knowing the material. Of course, knowing the material, the kind of knowledge that you shared with us is incredible. I mean, your control on it, obviously it's what you do, and there's so much control on that, but also how we can translate this knowledge to our students, who will then tell us, who we can then say, okay, this is the way this material is applied, this is the kind of sequences that you need to keep in mind. This is the kind of back-end preparation that a material like this needs, or this is the kind of detail that it develops. Right? So just some ideas over there. If you could tell us something on the face of it, and then maybe come back.
That's a very good question, and I'm going to actually answer that with an example. And so, for example, we talked about this company Mogu, who's created these acoustic tiles that they're now selling. They're made out of mycelium. One thing I'm learning is, and a lot of these companies, and we work directly with them, both as the facilitators and sometimes just listing them to different entities. The first thing is, when you create a kind of complex material like this that nobody's used before, these companies themselves are releasing toolkits that come with them. So you will find that instead of one specification sheet, a company like Mogu is providing 6 to 7 data sheets. There'll be an installation guide, there'll be a careful maintenance guide, there'll be a this is how you deal with it in an external application. I think your concerns, I suppose I want to say, are answered to an extent. These manufacturers of strange and unfamiliar products are recognizing that there are so many questions, and if students or practitioners want to use them, that the FAQs have to be much, much larger than traditional materials. And then, not to toot our own horn, I would say that's where some of the facilitators come into play, especially from an educational perspective or a consulting perspective. We are called in often to answer all those questions, to be the intermediary, and to really help people, because it's true, these are exciting materials, but it's a new landscape. And I think there is a willingness to communicate information, and there's access to lots of different entities, whether it's the scientists and the manufacturers themselves, or the facilitators like us, or libraries. There are plenty of resources to answer and implement these materials. Yeah.
There is also this question about, have you ever thought of working with traditional materials? I mean, there were certain instances, I think in your presentation, there was some instance, but what is your take on this? Srijani has asked this question.
Absolutely. Well, I think great question, because almost always, I don't think many new materials are out there right now, but I don't think anything comes from a vacuum. I think almost always everybody's influenced by something that was made centuries ago and needs to be revived. For example, even something like terrazzo. Why is it back in trend right now? Because we see the value in that traditional material. We see that it's a great way to use different waste. Why are we looking at clay-based materials right now? So I think it's also a periodic resurgence. There is so much tremendous value in these traditional materials that we've always used. It's just that plastic or synthetic materials have sometimes transplanted them in practice for cheapness, for their efficiency and mass production. But I think there's a huge resurgence right now, and all of these material makers are in some way or another influenced by traditional technology and knowledge, because you can't ignore that. It's such a wealth of knowledge. So I think there's plenty of materials out there who are trying just to do that, pull the best from tradition.
Yeah. We are actually running really tight on time now. How much is your presentation pending?
So it's just the activity, and actually what I can do is the activity and the assignment can just be left with everyone. Maybe everyone who wants to do it, you can just screenshot it. Maybe that's a good way. You can do a little screenshot and you can think about it. How about that? Is that a good idea?
Yeah. No, and not think about it. We are insisting, like teachers that we are insisting that the activity be done.
Okay. Great. Perfect. All right. So I'll just introduce this small activity and assignment to you all. It's something that we've developed ourselves. Hopefully it can be something that helps you take something concrete away from the session. Let me just present now, and hopefully everyone can see my screen, right? Perfect. All right. If everyone can see my screen, Aruna, say yes.
Yeah.
Perfect. Okay. I will not spend too much time on this. We're short on time, but this is my activity. And I think each person should not spend more than about 10-15 minutes on this. You can see there's three kind of columns here that are fully populated, different types of raw material, different types of processes that you can apply to these raw materials, and I would say the impact that you'd like to have with this. So what I want you to really do is to kind of pick something from the leftmost column, then the one in the middle, then the one in the one after that, and all the way down, and I want you to build your own material. The reason I've put question marks is I know it's very easy to say food waste, but I'd like you to consider where that food waste is coming from. Is this coming from a restaurant? Is this food waste from the grocery industry? Is it food waste that's coming from agricultural practices? I want you to lend it that specificity. And then if you've chosen food waste coming from a particular source, I want you to consider how you would turn that food waste into something valuable. Would you weave it? Would you incinerate it to create some kind of suit? Would you crunch it up and bind it into a new kind of composite? Would you turn it into a glaze? And then the driver of all of this, inventing a new material, is the impact that you'd like to have. Would you like to consume waste? Is there a local community that you want to impact? And then again, there's question marks in here about what exact application you'd like to have. Maybe you want to build furniture with it. Maybe it needs to be facade panels. Maybe it needs to be masonry. But I think your 10 to 15 minute task is, considering all this inspiration that you have today, I want you to build your own material and give it as much specificity as you can. And I hope that someday, and you can reach out to us for this if you want to do this, you have the means to either build or assist in building this material in real life. So that's kind of my goal. And I'm going to leave this assignment here, which Aruna, you said you're insisting that all the faculty do. This is definitely a lot more geared to the faculty members. I want you to think about 3 resources that you would like to add to your course or your teaching. This could be physical resources. This could be access to libraries, human beings, tools, things that you want to, based on this session, you're like, oh my God, I really need to incorporate this into my course currently. And then I want you to think of the human resources aspect. Are there professionals out there in the world, collaborators who you think you need to pull into this? Obviously, the goal is to create better materials knowledge and implementation for your students. But who are those professionals that you'd like to work with? The more unconventional, the better. Who can you pull in into creating this vision that you have? And then what physical outcomes would you like to have? Do you want to build a physical building out of these interesting materials? Do you want students to invent a new masonry? Do you want students to create a toolkit or to work with local communities? What is the physical outcome you want? And I want you to turn this into like a one-page vision. I think that would be really exciting if you take away all that you wish to achieve and how you want to bring change to materials education in your course, in your research, in your teaching. So yeah, if you guys want, just screenshot this page. That'll hopefully help you, and then you can screenshot the previous page as well. So
I know we are overshooting time. We have a couple of more minutes to explain the assignment a little slowly. I think we are we're not following all your aspects. Just a bit.
Okay, sure.
And then we'll close. Thanks.
Perfect. The assignment or the activity? Assignment. Okay, perfect.
You can just explain the assignment a little slowly.
Okay, perfect. So essentially, I think my goal really is to say, hey guys, you've kind of looked at some wonderful examples, both of different entities out there, different types of manufacturers, players, themes. What is this vision that you have for your course or your research or practice? Because you could be educators here, you could be, you have your independent practices, you probably have research projects that you're pursuing individually. If you have a vision coming out of this presentation for how you want to incorporate materials knowledge or make it better, what are the 3 resources that you want to add? These could be physical resources. These could be, I really want to create 2 shelves of displays, and I want to create, or I want to have a small making station. It could be different physical or non-physical resources that you want to pull in. And then, because nothing in life is possible alone, it's important to work together with people. I want you to think of 3 professionals or collaborators who you really need to execute this plan. It could be a landscape designer. It could be it could be a chef. It could be someone who you think will help you achieve this vision. The more unconventional, the better. And then I think what would be interesting is to see what physical outcomes you want. Do you want your students or your colleagues at your firm to be able to invent your own materials? Do you want your clients, like, what is the outcome that you would like to achieve? And using these three things as a starting point, what is your vision really coming out of this? If you had the opportunity to bring materials, education, and knowledge into a stronger capacity in your firm or university, how are you going to do it? Okay, hopefully that helps, guys.
Thank you. Thank you,
Okay.
Purva. And because we have Chiranjit sir and
Yes.
Gurpreet already here with us.
Absolutely.
So, but thanks a lot for this totally out of the, I mean, it's not even in our universe. That's where we are.
So
Some of
glad.
us would be, I mean, you're talking about eggshells and we're talking about grass and you're talking about glue like a screw and
Yes.
yeah, and so this
Perfect.
it's so much to think about. It's actually
Yeah.
literally like exploding your world.
Perfect. I'm
So
so happy.
yeah,
I will not. I won't encroach on the time. I will say, Arun, I just saw one question. I know a lot of people says, how can we understand or learn more about these materials? Guys, we are. It's our job, both in a professional and educational capacity. So actually, I don't know if I ended on a page. There's our contact, materialdriven.com. Find my email. Write me an email. I'm sure I'd be happy to help. But we do work in a very direct
Purva,
capacity.
maybe you can post your
Yes.
share your link website
Yes.
contact on the chat, and
Absolutely. I
we
will do
will
that.
start with our other session very
Exactly.
quickly.
Perfect.
Yeah.
Thank you so much.
So
I will. I
we'll
will.
request everybody to contact Purva. Yeah, there she is. She's written.